Okay, in this video, we're going to talk about independence. And independence is an extremely important topic in AP statistics. And we're just going to start to develop it here. We'll spend more time with it, a substantial amount more time. And when we get into probability, which will be the next unit, and then we'll spend a little more time with it again, independence again, when we get into inferences, or the very last unit of AP statistics. So very, very important that you get a good handle on it. And that starts with now. So please, if you got questions, make sure you ask. So events are said to be, two events are considered to be independent if the probability of one does not impact the other. Categories are independent, then they are proportional. All right. So I want to make a couple notes of this. If they're independent, they're proportional, there's no relation or association. So let's think about this. If you're dating and you're in a relationship, we associate you with the person that you're dated with. So if you're in a relationship, there is an association. Now, that also means you're not independent. All right, you're not independent. That means you can't go around and be looking at other people because you're in a relationship. So, and mathematically, it means it's not proportional. On the other hand, if you're independent, you're not in a relationship, we don't associate you with another person, but things must be proportional. All right, so mathematically, it's going to be proportional, but independent, there's not a relationship, there's not an association, no relation or association, but mathematically it's proportional. If it's not proportional, then it's not independent, and there is a relationship or an association. Or we can say it's dependent, as in you kind of depend on the person or rely on the person that you have a relationship, much like a child tends to rely on their parents. All right, so because there's a relationship there, hopefully. So the following table provides the results which relates a person's IQ to a person's dominant hand. The nice thing about whenever we have one of these two-way tables, which is one of the ways we display things, is rows and columns always sum up. So the 190 plus a 10 sum up to 200. This sums up to 1800. And then it also sums up vertically as well. So what we wanted to know is whether or not, and we can ignore this for just a moment, we wanted to know whether or not there was a relationship between being right, between your dominant hand and your IQ. So we have, here's our dominant hand, either right-handed or left-handed, and apparently we surveyed 1900 the dominant who were right, and 100 who were left-handed, and these were the groups. So out of the right-handed dominant, 190 out of 1900 had high IQ, which is 10%. 10 out of 100, or 10%, who were left-handed, because all we did was 10 divided by 100 and got that. And so we look at these percentages and they're equal. So regardless of whether or not you're left-handed or right-handed, there's an equal chance that you had high IQ. So basically, if I went to someone and knew that they were left-handed, there's a 10% chance that they had a high IQ. If they're right-handed, there's a 10% chance they had a high IQ. So because they're equal, there really was no difference. So there's not a relationship there. There's not a relationship between high IQ and being left-handed. I couldn't make a prediction based on that. However, when I go back to the Pew Research poll that we talked about briefly in the other video, we do have a relationship. And here's how I say that. When I look first off at the Democrats, 44% of Asians were Democrat, whereas 67% of the blacks were. So consequently, the segments do not match. Because the segments from one to the next do not match, they're not proportional, because basically 44 and 44 are not the same. So not proportional. Because they're not proportional, then there is a relationship. So there's not proportional therefore a relationship. And therefore not independent. The same thing can be said for the graph below. And we can see real quickly that this doesn't match this, doesn't match this, doesn't match this, and doesn't match this. In this case, when I was looking at these, this is independent, this is independent, this is independent, independent. And because this is just over 40%, this is a little, this one is under 30%, under 40, and because they don't match, because they're not matching or they're not proportional, they don't have the same percentage, they are not independent. So looking on to the segmented bar chart, we can see much the same thing, because and a segmented bar chart shows independence very nicely, because the segments would have had to be exactly the same size. And clearly we have 44%, 67%, 43%, and 26%. So they're not the same things, so they don't match, okay? So using the segmented bar chart, we're going to ask some questions, all right? So our first question is, can we say that there are more than twice as many Black Democrats as there are Black independents? And we need to justify our response. But when I look at this, I'm looking at the Black column. I go, you know what? There's 67% Democrat. There's 27% Black independents. This percent is obviously twice as that. But they didn't ask me about the percent. They asked me whether or not are there twice as many. You have to be careful. I can easily say the proportion is twice as big, but the as many, I can only do that if I'm working in the same column. And since I'm working in the same column here, I can definitely make that claim. So in this case, we can definitely say, yes, 67% of Blacks are Democrats and only 27% of Blacks are independent. We can definitely make the claim that, that there's twice as many, but only because we're operating in the same column. When we get to the next problem, it changes up just a bit. The next problem says, can we say that there are twice as many Blacks as there are white Republicans? All right, and we have to be really careful there. So can we say there are twice as many Blacks as there are white Republicans? Well, when I look at the Black Democrats, we have 67%, and I have 33% white Republicans. Well, the proportion is twice as big, but we're not operating in the same column, so we can't make that claim. So the question is why? Well, I don't know the size of the population. I don't know how many Blacks there are, and I don't know how many whites there are. Maybe there's 1,000 whites and only 100 Blacks, in which case there'd be 67 versus 330. We don't know. We don't know the relationship, so we can't make the claim. So from across columns, I can talk about the proportion, but I can't talk about the actual numerical value. All right. So in that particular case, I can't talk about the numerical value. I have to be really careful about that. So no, we cannot. 26% of whites are Democrat and 67% of Blacks are Democrat. Excuse me, this should say whites are Republican and 67% of Blacks, but we don't know how many white people versus Black people there are. So since we don't know the actual numbers, we can't do that. We can't go across columns. The next part says, can we say, number 3 says, can we say that the number of Hispanic independents is about the same as the number of white independents? When I look at this, it's like, okay, Hispanic and white independents. And I look at them and I go, you know what? The Hispanic is 37, the white is 37. So yeah, the proportions are about the same. We have 37% in both of these. But once again, I went cross column, and I don't know how many Hispanics there are, and I don't know how many whites there are. So I cannot say for the same reason, I don't know how many. I just know proportionally they're about the same, but I do not know the actual number because it's cross column. The last one is fairly easy. Does political affiliation appear to be related to race? What they're asking when they ask you, are they related, is there association, which means, are they independent? And remember, to be independent, they must be proportional. They have to have the same percentages. And clearly, the segments across do not match. Each segment seems to vary quite a bit. And since the segments do not match, we can say, nope, they are not independent. Therefore, there is a relationship. The distributions are different. The percentages are not the same. Therefore, they're not independent. Party affiliation appears to be related to race. And once again, just want to say this real quickly. To be independent, oops, covering up things I don't want to. Slide that up just a little higher. Independent, they must be proportional. Well, they were not proportional, so that means that so that if they're not proportional, that means there's a relationship. All right. If they are proportional, they have the same percents. Those didn't. They had different percents. So since they had different percents, we're down here, and that means there's a relationship. All right, moving on to the next question. The next question was based on an AP question, although this isn't one. It's kind of scary initially. All right. So based on the 2017 research poll, party affiliation and race are not independent. So this is the reality. They're not independent. However, for this exercise, it says assume. We're going to pretend that they are independent. All right, we're going to act like they are independent. Reality, or based on 2007, they're not. They're based on 2017, they are not independent, but we're going to act like they are. And they want to say that it follows the all race distribution. Create a key and fill in the segments for each by race. So they gave us the race here, and they want us to fill in this chart. How do we do that? Well, they gave us a big hint. If they're independent, if they are independent, the proportions must be the same. And so this is what it would look like. So the proportion of independents are going to be the same. The proportion of others will be the same. And remember, that is always true if they're independent. To be independent, you're going to have the same proportions or percentages. All right. The next problem. Find the table value that results in perfect independence. And this is always a tricky question for students. But to be independent, they must be proportional. Oh, so that just means I need to set up a proportion. So 133 over 105 equals 95 over x. And I multiply the two numbers on the diagonal and divide by the third. So 105 times 95 over 133. When I do that, I end up getting 75. Finally, it says, given that the grades and statistics are independent of gender, complete the table below. Well, I have a lot of blanks, but remember, rows and columns add up. So 30 plus 50 is 80, plus 20 is 100. And 30 plus some number has to add up to 54. Well, that number is 24. And from this point on, I can fill in the rest of the table. I can sit there and go 30 over 50 equals 24 over t, and solve by proportion. and I can fill in the rest of the table that way. Okay? All right. So that closes out the discussion on independence. The next one will be on contingency tables.